Hey everyone, today we're going to talk about what are fossils. And so you should have either the e copy of your fossil note guide or you have the paper copy in front of you, depending on whether or not we are doing e learning, or you have the paper copy because you managed to get one of those before. So, what are fossils? Fossils are traces or imprints of once living organisms such as animals, plants, bacteria, or fungi that are preserved in rocks. We've talked a lot about fossils, right? We've talked about how uh, we've seen the change over time and we've watched the video. And so now we're going to talk about like how are fossils actually made and what are they exactly? So we have body or unaltered fossils. These are actual parts of the organism, such as an insect trapped in amber, or the Iceman who was trapped in ice. So these are formed when they are trapped in something, amber or ice, for example. So they are the actual organism. There has not been change. They've been frozen, sometimes literally, in time. The second type of fossils, trace fossils. These are the ones that we see a lot more often. And there's actually, let's see here, four different types. A, or type 1, a replacement or mold, which is a reproduction of the inside or outside of a living thing. And that's what we see up here in the upper left-hand corner or down here. This is the inside of a shell. This is the outside of some different plants, it looks like. Then we have permanent mineralization. This is a duplicate of the original organism. Usually, often it's their bones, and that's where their organic molecules are replaced with inorganic molecules. And you'll often hear this called petrification. So, petrification is the same as permineralization. Permineralization actually is more accurate because you are replacing molecules with minerals. Okay, more trace fossils. We have burrows or borings, and that's what we have down here. So it's spaces dug out by living things and then preserved. Or we have tracks, footprints or paw prints. This looks like some type of possum, maybe. We got something with 4 digits, it looks like. And that has to happen on something like mud or sand, and that has to be covered really quickly with something so it doesn't get washed away with water. So organisms have to be buried in the earth, and these layers have to be can be mud, lava, or water. And when we have the different types of layers, we end up making sedimentary rock. Um, if it is lava, you're not going to see the lava has to go on top of that sedimentary rock because, like we said, the lava is actually too hot for fossils to be there. Okay. What are the two conditions that result in fossils? We need to have hard body parts like bones or exoskeletons. So we have bones. Insects, shellfish, some types of plants have harder exoskeletons. And we need a quick burial or a lack of oxygen. Just the other day, we finished watching the Story of the Earth movie, and we saw that very first primate. It got that toxic gas, and then it fell into a very, very deep lake, and that was a lack of oxygen. So it was both kind of a quick burial and the lack of oxygen in that case. Okay, so let's think about so fossils don't just tell us that an animal was there, but it can also give us hints to what the environment would have been like at that time. So let's kind of see what we can think of. So if we are looking at this, and if we didn't have the background of snow, um, did we see a polar bear? What type of environment do we think a polar bear is going to be more likely to live in? Do we think we're going to see something that we can tell from its there's certain structures in the bone that would tell us that it's carrying a lot of extra weight, so it's probably got lots of fat. We're going to know that it's probably something that carries a lot of fat is not going to live in a very warm environment versus a very cold environment, right? We just kind of know this. So if we see we're out here in this very sandy environment and we find an artifact that looks like this, a fossil, we clearly see this as a fish. What are we going to think? The fish is a fish that looks like this going to be it's living in the sand? Absolutely not. What that tells us is that this used to be an ocean and it's either been pushed up, so it's now dried out, or the water levels have lowered to the point where there's no longer water. One of those two things has to have happened there. For instance, if like areas that have a fair amount of water and a fair amount of shade. So if we see a fern-like plant in a place that is now hot and dry and I don't see any shade there, right? That's going to tell us that in the past, that area must have had trees and must have had a lot more water available than it does today. Here's a quote about what we can predict from things like frogs. Remember, frogs are amphibians, they have to have water nearby. So that means if we see frogs, that the habitat has been wet because it has to be wet in order to breed. So that tells us a lot about an environment if we can identify whatever that animal is. Okay, now let's see what you can infer. We have the woolly mammoth on the left-hand side, the Asian elephant on the right-hand side. What can we, and we know absolutely 100% that the Asian elephant is a descendant of the woolly mammoth. What can we say about what the woolly mammoth's climate must have been like? Go ahead, pause the video, think about it a little bit, maybe jot down a couple things. Obviously, they both have trunks, right? The only reason this one has a tusk just happens to be that elephant does. Some Asian elephants do have tusks, so that's not the big difference there. Look how tiny that mammoth's ears are. See that? And here's the Asian elephant's ears. We can't really see the woolly mammoth's tail, but it does have a tail. Obviously, the woolly mammoth is woolly. So things that can tell us, right? Well, animals that have more fur tend to be living in places that get a lot colder in the wintertime. Other things that we can say, animals that have small ears tend to have the small ears because it's more protective. Long ears are more likely to get frostbite. So we can probably say that the woolly mammoth lived in places that are much colder than the Asian elephant. Okay. Once upon a time, the ancient horse was about the size of a small dog, about 30 pounds. Got a Cocker Spaniel at home. It's about that size. The horse today looks very, very different, right? But there are some parts. We can see the back of its leg here. Looks very much like that. Some of the jaw looks similar. But what do we know? From the bones and the structure of the little Cocker Spaniel size Horse, this is what we think it looked like back in the day. It was still an herbivore. Look how its foot has changed. At one time, it actually did have a paw with 4 toes. And as the time changed, we see that the nails changed a lot. By this time, there's a small hoof, but there's still 2 other toes there. And then this is pretty much the modern day horse. Here's just the bones, so we can like focus on the bones a little bit more. And we can see that here we're getting more and more of a hoof-like structure. And here's the point where we've gotten down to just the 3. And these probably aren't really touching the ground. And they've either fused or come up here and fused into this bone. It's hard to tell between those 2. And then here's 5 different horses at different times. So 60 million years ago, which would be... So 60 million years ago was about 5 million years after the dinosaurs were wiped out. So this is when it was at its smallest point. And remember, the only mammals that had survived the whole extinction event were really small. We're talking about something the size of no larger than like a large rat. So it took about 5 million years to go from like a large rat to animals that were about the size of, like I was thinking, a Cocker Spaniel, smallish sized dog. 40 million years, so 20 million years later is a little bit bigger. We can see now that it looks more like a horse, today's horse. 25 million years ago, looks like a clunky horse. Its tail's gotten a little closer to what we would recognize today. Its jaw has gotten bigger. Maybe it's eating more chewy or thicker food. And by 10 million years ago, we've got something that's smaller than the modern day horse, but looks pretty much like the horse we would recognize today. Wrapping it up, conclusions. Fossils are only formed under very special conditions. They give us clues about what life is like long ago, including the environment that they lived in. They help us understand that plant and animal species change over time. We have mentioned that certain fossils are known for certain periods. Like the trilobite got wiped out in this very first mass extinction, the Ordovician and Silurian extinction. So index fossils are a distinctive, abundant fossil found in a wide area, but only for there in a very limited time. And so, like I said, there's a trilobite. These are some of the others that are well known. A lot of them are ocean organisms, because remember, oceans cover at least 70% of our planet at any specific time. That is all we got, guys. If you have any trouble, send me a message. Talk to you later.